Okay, back at it. Let's go back, circle around, and talk specifically about the supercharger. Since I just talked about it and didn't make notes. 5, supercharger. I wrote internal supercharger here, but because that's where most of them are, we'll just call it a supercharger. Supercharger. Well, the parts consist of one. What do we have?
Belt.
I was thinking internal. So
Impeller.
yeah, impeller. So, but we'll put gear driven. Could be belt driven. That'd be external. Gear driven centrifugal compressor. And, come on, don't make Phil cry. What goes along with the centrifugal compressor? What's the next thing after the compressor? He's going to be so happy. A diffuser. So the fuel-air mix is drawn into, which part of the compressor?
The turbine.
The compressor. Where does the air enter? Center. Into center of compressor. Center of compressor. And thrown outward and thrown outward into diffuser. Now, as I've mentioned a few times, like I know the Lycoming R680 9-cylinder radial has a thing that looks exactly like an internal supercharger and diffuser, although they just call it I got Biscoff cough now. And I'm out of water. Hang on a second. Okay, the Lycoming R680 has what looks like an internal supercharger. They call it a diffuser, but it's an impeller with a diffuser, but they call it the diffuser section because it doesn't boost manifold pressure. It's spun at a ratio that just brings in the air, keeps it pretty much at the same pressure, but it brings in the fuel-air mixture and spins it out and diffuses it. And so what it does is it provides a much better fuel-air mixture to the engine, a more uniform to all the cylinders, rather than letting it come in and trying to find all the 9 cylinders. Which, the more I think about it, 9 cylinders have that, the 7 don't. I wonder if that was the deciding thing. When you got to 9, it was too many. I don't know. So fuel-air mixtures. This does provides better fuel-air mix distribution. So there's that benefit. So we got to the diffuser, which, by the way, it does provide a nice diffusion and distribution of the fuel-air mixture as a nice added benefit. From the diffuser, it goes diffuser to, what would be the next thing? Right, intake pipes, very good.
So it's a FA mix?
Fuel air.
Not just air?
Mm-hmm.
For the intake? So where does the fuel come in?
Carburetor bolts right to the engine, right before the supercharger.
So what if it's fuel injected and just goes straight? It's just air then?
Radials never had fuel injection that I'm aware of.
Oh, these are specifically on radials?
Yeah.
Okay.
And we could talk about like the Allison V12s. Not that I've ever worked on one of those, but I've seen the drawings, and has the big PR58 carburetor, pressure carburetor, bolts on the back of the engine, goes into the engine. Next thing it hits, supercharger. So of all the aircraft that I'm aware of, using the internal supercharger, it is going to be a fuel-air mixture off a pressure carburetor going into it. So from diffuser, it's going to go the intake pipes. Obviously, from the intake pipes, it then goes to two cylinders, and then out. Where is it usually? Mounted on the rear of the engine. On the rear of engine, rear of engine. Or between power section between the power section and accessory section, power section and accessory section of a radial. Some engines use a 2-speed compressor. You got your right pedal, you got your right rudder, left rudder, or it's a clutch on the other side. So 3 pedal, I'm just making that up. Push in the clutch, change shift gears, 2-speed compressor. Let me see, the Pratt and Whitney, yes, they do make piston engines. The R2800 is one of the ones that had it. I looked that up. It had a low speed. Low speed compressor was 7.29 to 1. So for every time the crankshaft goes around once, this is going to go around 7 times. And at a high speed of 8.5 to 1, and depending on some models, went as much as 9.45 to 1. So it really spun the heck out of it.
Would the supercharger know when to switch from low speed to high speed?
It will not know. It's literally
That's why you do it.
you do it. It's pilot controlled. 2-speed pilot controlled. And remember, a lot of this stuff is military planes. So you're going to military power. You're fighting a dogfight. You push this thing up, you know. Yep, or take it. I don't know. Take it off from a carrier. You might want like 9.5 to 1. Boost that thing. Get off the carrier. You got to conserve fuel. Get over to the. I was trying to think of an enemy's plane. Yamamoto's fleet over there. I know I get it. Yamamoto's fleet. Looking for the. So you're going to want to conserve as much fuel as you can for loitering time. Pull it back. Pull your boost back. Engage in your fight. Go up to high speed. I don't know. Not trained in that. Let me see. F. Because the compressor is directly tied to RPM, there is no need for additional controllers like the turbo. Because the compressor is directly tied to RPM, there is no need for additional controllers. Like the turbo. The turbo is going to have all kinds of controllers, and that's where we're going to spend most of the next 2 days. You're thinking, yeah, great. So yeah, I was going to say, well, in theory, because this compressor is then tied to the throttle, there would be this improbability of overboosting the engine, but that's not true. I met a guy who had a bolt-on supercharger on his Cessna 180, and it was just, man, that thing was packed in there so bad. But it was It was a fuel injected. It was a fuel injected engine with a supercharger on it. So there's one. So it just, but the fuel will be injected at the cylinders like always. So it was just air going through manifold like a normal. But as he explained to me, if he's in Tahoe or someplace high altitude, as he increases the throttle on the aircraft, then he would just watch his boost, and he'd pretty much go wide open throttle or get very close to it, and the boost would be where he wanted it to be. But when he took off from like down here, he could only give it like half throttle. So he'd just take off with half throttle, and there was enough power to things just leaped off the ground. All right, that's it for supercharging. Now let's go on to turbochargers. Turbocharger. All right, so turbocharger. It's an external compressor driven by turbine wheel that gets power from exhaust gases. So external compressor driven by exhaust gas. Across the turbine. Across the turbine wheel. Yep, that works. Basic operation. All right, we're going to look at this slide. So inlet air travels from cowling inlet, air filter, through air filter, I did write that, from the air filter into this pipe into the compressor. Middle of the compressor, it is flung outward. Air is now compressed. It's going to go through the pipes that make up the upper deck. Compressor, then to the throttle body, right there. From the throttle body, we now have what is called the intake manifold, where we read manifold pressure to the cylinders. Then from the cylinders, back out into the exhaust system. The exhaust system, it will get to a Y. That's not a question, that's a thing. That is the Y, because it looks like a Y sideways. When it gets to the Y, it has two choices. It can go straight, in this case, on up to the turbine wheel, or it will go through the wastegate. If the wastegate is open, then you will be wasting more exhaust gas, not as much pressure going across the turbine wheel. Turbine's going to go much slower. If this is mostly closed, it's never all the way closed. If it's mostly closed, then most of the air is going to come up here and spin the turbine up much faster. What determines this wastegate is basically the entire thing that we have to learn about turbochargers. It's all about the wastegate, because everything else just does its thing. I mean, that's what it looks like. But now we have to control the wastegate. And, spoiler alert, but the way you control the wastegate is just a variety of different ways, ranging from, believe it or not, like the Piper Senecas. These have a bolt with a nut and set at the factory. And put the bolt in about that far, and that blocks about as much wastegate you need. Lock it in. There we go. Can you adjust the bolt? Probably not after it's been running for a while. It's going to be pretty much weld itself in there. And why would you? It's set at the factory. If you need to change it, and it's like, well, why are we doing that? So from a bolt to a wastegate that is controlled inside the cabin, like throttle, just a manual wastegate. You just got another, you have throttle, prop, wastegate mixture. Now you got a whole nother knob in there. So I flew only one time in a plane like that. It was really weird. In fact, speaking of it, they're from up at Eagle's Nest. He got on the runway, took the center line, went firewall with the throttle, obviously props all the way in, and then he just started bringing the wastegate close until he got to the boost he wanted. He goes, there we are, feet off the brakes, and off you went. And then adjust it manually. It's a lot of workload.
Different color.
Huh? I don't even remember. I think it was just black. Green, yeah, green for go. So we have manual. We can have kind of a semi manual where the throttle lever is actually tied into this at the same time, so one lever is working both things. But most of them work on a principle of an automatic wastegate that uses oil pressure to control it, just as a means of hydraulic pressure across many controllers. So you can have there's this bolt on all these controllers, and this one does this one does that one does that, which we're going to look at all those. So basic operation, let's see, inlet air travels from cowling inlet through air filter. So inlet air travels from cowling inlet through air filter from air filter to center of compressor, the air is then pressed outwards. Air is compressed. Compressed outward and compressed. That's the whole thing. Let me see. I'm going to add something. So from compressor to possible intercooler. I wrote inner. I think some places call it intercooler. Not all aircraft have an intercooler system. Some just go right from the compressor right to the throttle body. So to throttle body. Then obviously 2 cylinders. Combustion air. Combustion. Air enters exhaust pipe. And travels to the Y, which is spelled W-Y-E. Yes. Combustion air enters exhaust pipe and travels to the Y. From the Y, some gas, I don't know why it's with exhaust, it's exhaust gases, not exhaust gas. Some gases flow overboard and some flow to turbine wheel. Flow to turbine to drive compressor. Tell me when you're all caught up, because that was fast.
The compressor forcing more air in also causes there to be more exhaust gases, which will send it faster, causing more weight.
Yeah, called bootstrapping. So that's a term we're going to look at from the term pull yourself up by your own bootstraps. So yes, that's one of the controllers that we're going to look for, has to try and stop that from happening. So what he's asking is, can you get this situation where basically you add throttle, so more air now goes from the compressor into the cylinders, which causes more exhaust gas, which causes the compressor to turn faster, which cause more air to enter into manifold, which then causes more exhaust gases, and you just get, yes, that's exactly what can happen. All right, components. Components. Well, the main component's going to be the, as an assembly,
The turbo.
turbo. Keep thinking of that red-green show. Call it a Kaibo charger. So modern turbo housings are made of Inconel. Heard that name before? Where?
Fire detection.
Ah. In recips, we used it too, are made of Inconel. Same stuff you make exhaust valves out of. Why? Because turbine temps yeah, I'm going to say turbine inlet temps. Turbine inlet temps can reach as high as 1650. I think you can go a little bit higher. So we've talked a lot about exhaust gas temperature probes in aircraft, piston engine aircraft. And I've always said there's no number, there's no red line at all for exhaust gas temps. It is what it is. You can only make it go so high. The one thing that is not that way is turbine inlet temps. They are redlined. You have a maximum, and you have to really be careful of that maximum. So when you're leaning out and you're watching your EGT rise, you're going to peak EGT, you got to be careful not to exceed that 1650 or you start melting turbo pieces. When turbos get really hot and exceed their temperature because they're spinning so fast, they stretch. And when they stretch, they start rubbing on the housing. And then when that happens, you got to get in there and file them. You got to get a new turbo. They are precision balanced rotating shaft with a radial flow turbine on one end and a centrifugal compressor on the other.
It's a turbo.
It is. Precision rotating shaft with a radial flow. Do you agree with the radial flow comment?
Is it a joke?
Because to me, radial is kind of this way. It comes in this way and it goes that way. So it comes from the outside and it goes this way. So it's kind of radial flow turbine, but that's what they call it. On one end and a centrifugal compressor on the other. Why are they precision balanced?
Extreme RPMs.
What's that?
Extreme RPM.
They spin fast. Turbos spin from about 2,000 RPM on the low side to as much as, or maybe more now, 125,000 RPM. And that was shocking to me, so I did the math. That is 2,083 revs per second. That's RPS, I guess, revolutions per second. So they're really moving.
It's fast.
I counted it.
Did you?
Use your fingers.
Huh?
Did you use your fingers?
Yeah, it was really hard to get 125,000. Start over like 5 times.
Fingers and toes.
That was the same summer I counted to infinity twice. It has a pressure-fed pressure fed, pressure oil fed. That's what the words that I want to come out. Pressure oil fed plain bearing. Constant oil pressure is critical. If you don't have pressure fed across plane bearings, then you got metal on metal, and it won't last very long at all. There's a lot of problems associated with this particular system from a standpoint of the engineers created it. It works absolutely well until mechanics get involved. And then things start to have problems because it is pressure fed and there's a check valve in there. And a check valve is a one-way valve that allows oil to go in one way and keep it flowing the other way. And occasionally mechanics put the check valve in backwards, which means it's no longer pressure fed, it is nothing fed. And so they turbocharge only lasts a couple of minutes. And then what usually happens is the customer comes back and complains that their turbo now failed. So the mechanic blames the turbocharger company. They call them up and tell them they want warranty. They send it in. And then at that point, the turbocharger says, well, you didn't run any oil through it. Did you check? And also, when you sent it back, you even left the check valve in backwards. And so you know exactly what happened. So you got to be careful with that. Always pay attention. Constant oil pressure is critical. Let me see. Where do we get the oil? Supplied by what? Engine-driven pump. It's usually about 30 to 50 psi, which is about what the engine's going to put out anyway, at about 1 to 2 quarts per minute. And occasionally the oil is returned through a scavenge pump. My wife was telling me a story about somebody, they lost a lot of blood, and she was like, yeah, they lost a lot of blood. She gave me like the number, yeah, I lost like 3 liters, and they had to give me like X number of pints. I'm like, why are you telling me a story that's mixing imperial? I can't do the math here. You got to put it all together for me. If they lost X number of liters, how many liters they give them back? You can't lose liters and give them pints. Nobody knows how to do that.
Equal to about 5 hamburgers.
Huh?
Equal to about 5 hamburgers.
Yes.
Americans lose that.
What's that?
I was going to say, I thought the average human body only has 3 liters.
I did
Or am I
too.
thinking?
I don't know. I've never really.
It's like, what is really
Last
bad
time
day?
I drained a body and measured it,
Shit out of CNC over here.
Stop the blood. I don't care how much is in there.
All right, so speaking of the pressure oil-fed bearing, and I didn't put this in my notes, but it's really worth pointing out that oil cokes at a certain temperature.
Is it, no.
And anybody remember that temperature? Because I forgot off the top of my head here. 500. 500. It's around 500. Should have wrote it
Go back
down.
to the notes.
Right here. Oil cokes when it's heated above 300 degrees Celsius or 575 Fahrenheit. So let's just go with the 575. So we're talking all the same thing. And we have exhaust gas coming in at a nice warm temperature of 1650. So I am going to imagine that the shaft and the turbine right there, the turbine and thus the shaft, is probably going to get a little warmer than 575 degrees. So so if the oil cokes up in there and these plain bearings, then it's going to squeak. Yeah, it's going to get a little grindy. So you don't want that. So people with turbocharged aircraft who like their turbocharged aircraft, you will see them do a long cool down period where they will taxi up and they will sit there and let their engine run for quite some time, waiting for that turbine spinning to cool down, because the exhaust gas at that point is not that hot. It's much, much cooler. So let everything cool down, so when you shut it down, it doesn't coke. It's not coking now because it's not spending enough time in there. It goes in and then out. So the oil is not heated up that much, but if you have a shaft that's 575, 600 degrees or more, and you stop it and the oil stops flowing, then the oil is going to sit there and coke up. So you don't want that. So you want to keep the oil flowing and then cool everything down and then shut the engine down when the shaft is below coking temperature. All right, so you have the pressure oil fed bearings. That pretty much describes the entire turbo system right there. There's not much more to it than a shaft with turbine on one side, compressor on the other, oil fed bearings in the middle, and a housing. That's what it is. All right, then we have the Y, which is the path to either turbo or exhaust. So that's path provides to either turbo or exhaust. Turbo or overboard? I don't know, what do you like? Turbo or overboard. And I'm aware of time. Nah, doesn't work for me.
Is the engine-driven oil pump a separate oil pump?
Same one.
It's the same oil.
Same oil pump.
So does it just have like a
External fitting.
another line that just bleeds off of it?
Yep. All right, then we got the wastegate, which is the brains of the operation, if you will. The wastegate. Let's talk about the wastegate. Oh, there's our turbo. We already looked at that. That's another turbo with a bunch of stuff bolted onto it, which we'll come back to. There is our wastegate. For the Rotax use an electronic wastegate, which is kind of cool. But legacy aircraft do not. So it looks a lot like a throttle body right there with a butterfly valve in there. There's a little butterfly valve. And we got a spring right there, which is going to spring load it, which looks like to open. So if it's open, that is going to default to overboard, lower turbo speed, turbo off, we'll call it. All right, we got a piston with a spring in there. So the spring, we're just going to also push this piston all the way back. So this right here is its relaxed normal state, which would be, we're going to use the terms turbo on, turbo off, just to kind of help everybody, right? So this is its normal relaxed state, 2 springs holding it open, so that is turbo off mode. It's going to go overboard. Keep in mind that the turbo is never actually off because it can't sit in one spot, because if it did during operation, sat in one spot, exhaust gas hitting one spot on the turbine wheel causes cracking, and so it's always in some sort of rotational mode, but we'll call it turbo off. So what happens is oil comes in to here and flows out. And so if we want the turbo on, we need to close this piston, which will cause the butterfly to close. So since this is the oil in port and that's the out port, the only thing I need to do to turn this thing on is plug the outlet port off. If I plug the outlet port, this will have oil pressure from the engine. We'll start pushing on the piston, closing the wastegate, causing the turbo to come on more. So that's what we're going to look at. So oil is going to come in, and now we're going to add controllers on the outlet side of this. So the controller is either going to drain oil and let this thing go to its relaxed state, turbo off, or it's going to block oil, causing the butterfly to close. Now, just like a throttle, it's not an all or nothing situation. It's usually in some little spot in there trying to control the turbochargers and moving around a little bit at all times, doing this little thing as the controllers are trying to get it to do what it's got to do. All right, come back to that one. All right, so the wastegate. It is a valve located in the exhaust line. So a valve located in the exhaust line. When open, exhaust gases leave exhaust, bypass turbo to overboard. Exhaust gases, I'll just put, are vented overboard or routed over. I like routed better. Are routed overboard, and that is turbo off. When closed, exhaust gases are routed to turbo, which is turbo on. Tell me when I'm good to move here. Yeah? Everybody's good?
No.
No? Well, you take it up with him.
It's not the best of me.
It's not your wife. Are you done?
Yeah.
You good? Well, you gotta say so. All right, 3 basic types of wastegates. Until I can think of another one. 3 basic types of wastegates. One is the fixed type. The other type's going to be the broken type. Uses an adjustable screw, I think bolt's a better word, to block a certain amount of exhaust to the turbo. So fixed uses a bolt to block a fixed amount of exhaust. So I said the Piper Senecas have that.
So sent by the manufacturer, you said.
Yep, it's set at the factory, and I remember I think it was Lycoming School or something. We were talking about turbochargers, and and it was the whole, all right. So, and he gives this big scenario with this type, and and they come in, and not reaching critical altitude, you're not getting the boost you want, blah blah blah. How do you fix it? Of course, the answer is he was looking for, and I think that was me. It fell right into it. Well, you screw the bolt in, So you screw the bolt in, will stop more from going overboard, mower to the turbo. And it's, no! Number one, you're probably never going to get that bolt to move. I'm like, that is a good point. You guys ever try to take an exhaust off a car? You need what they call a Victor wrench. Victor is the ones that make cutting torches. Right? So you don't usually, they call it Victor wrench. So you don't usually undo bolts that have been in an exhaust system in operation. So this one is directly in line with the exhaust, with the threads and everything being blasted on. You're not going to move it. And he's like, no. Your course of action should be, why is it not doing what it's supposed to be doing? Because the bolt didn't move, something else changed. What changed? Go fix that. Don't try and fix this bolt. Then you're just masking the problem. It's going to keep getting worse and worse until it doesn't work. So anyway, but uses a fixed bolt, and I don't really think you can adjust that if you wanted to. Let me see. Number 2. Where am I at here? 3 back 2. Manually operated. Manually operated. All right, manual controlled system. That's what I was explaining to you. It was like the type I flew with that guy with the 182, with just the extra knob on it. So here's an example of what that is. Now notice there is a pressure relief valve right there. It is not connected to anything. I think in car you call it a pop-off valve. The what? Blow-off valve? Okay. So that is just a safety device. So it's set at a certain pressure. So if the pilot spills their beer and they're looking all over the floor to pick up their beer, not paying attention, overboost it, this thing will pop off and keep the pressure in the upper deck line, or manifold pressure, be more exact, manifold pressure from exceeding set limits. It just opens up and bleeds off the pressure. It's just a dummy valve right there. But otherwise, and I don't know what that, it looks like it's a faucet kind of a drawing there that they tried to draw. I can never figure out what that is over there if it's missing something. But anyway, it's just a wastegate that is manually operated, pilot controlled, little faucet knob, I guess, is what they're trying to depict here. But it's a push-pull cable that will go to the cockpit. And so if the pilot wants more turbo, you would close that, just like you're closing the wastegate, just a manual wastegate, causing more exhaust gases to go across the turbine, which will cause the compressor to speed up, causing more pressure into here until either such time the pilot gets the desired amount of pressure or the pressure relief valve starts barking off on you. Manual. That is the manual. Does anybody have a car with a turbocharger with that kind of? Can you hear your valves pop off?
Yeah. Whenever let go of the throttle, it just rolls off and makes that cool sound.
It does make a cool sound.
It makes a cool sound.
The first time I heard that sound, I almost pooped myself because my son and I were in Los Angeles, and he arranged for me to have a Ferrari, drive a Ferrari.
Nice.
And so I got on it, and that thing was so amazing. The steering wheel had the tachometer in it, and so I put it in manual, and I thought I would shift into second, and I mean, it just went boom, to smack to red line so fast, and I backed off, and then everything started popping. Like, I just broke this car, man. I'm done. I'm done. I didn't get the operate. So you see, pilot manual operator. That is pilot controlled cable. So pilot operated push pull cable. Push pull cable. Or it could be. Oops, that's maybe a one. Or it could have an interconnected to throttle. Maybe I think the next picture might have had that. Let me see. Yeah, there we go. Interconnected to the throttle. So the pilot just has the throttle knob, and that throttle then basically goes out with two cables. One cable is going to go to the throttle because it's called the throttle, and the other one's just going to automatically go over here to the wastegate. And so it's going to be kind of calibrated so that as you open the throttle, it will adjust the wastegate so that you're getting the correct amount of boost as you need going forward. But it's just manual. And of course, we still have the pressure relief safety valve. Or interconnected to throttle. Let me see. And as I just mentioned, the manual systems, and a lot of other systems too. Manual systems use a pressure relief valve. Pop-off valve. Relief valve in the upper deck. Let me see, in the upper deck. I wrote upper deck. You could put it in the manifold. I wouldn't be surprised if one manufacturer doesn't. The thing you kind of have to realize with these systems is, I'll finish this sentence, and then in the upper deck, to keep pressure within set limits. The weird part about this is it's not like Lycoming or Continental builds a system and then Continental or then Cessna or Beechcraft calls it, yeah, I want that one. It's kind of backwards. It's kind of like the manufacturer, Cessna, Beechcraft. They look over there and go, you know what, we want that engine, but we want it set up like this. We want a controller over here, another controller over there, we want one over here to do this. And so they're more of an airframe kind of style. So it's just a weird thing. So yeah, consider it an airframe styled system. It's whatever the airframe manufacturer wants on there. That's how it got there. So they can do some weird stuff. In fact, I was listening to some podcast about some system, and it was just completely goofball how they did it. And it was like, nobody knows why they did it that way. And it was, I forget which podcast it was. Yeah, one of the guys said, I think they just had a whole bunch of those things laying around, and it really didn't work for what they wanted it to, so they routed it backwards to kind of do something, and it was like, made no sense. But anyway, there we are. Good place to stop.